All right, now a few quick questions just to warm you up. What is the angle in degrees for pi over 3? It is 60 degrees. How do you know it's 60 degrees? 180 divided by 3, right? So if I have 2 pi over 3, that would be 120, because you have pi over 3 and you have 2 of them. So 120 degrees, okay? Now today we will also continue to talk about angles, but today in more specific content, we will talk about sine theta, cosine theta, and tangent theta. Now you learn all these three back in geometry, and if you're in chemistry right now, oh no, I mean physics right now, or last year, you should have seen these three already. So that should apply to most people. Now, what is sine theta? What is that equal to? Louder. Opposite of adjacent. Okay, so opposite over, wait, what? Opposite of adjacent? Okay, opposite of a hypotenuse, yes. Cosine theta is? And tangent theta is? Opposite over hypotenuse, okay. So, opposite over adjacent. Yes, opposite over adjacent, that's tangent. Now, there are a few things I want to say about these three functions in this classroom. I expect students to know how to pronounce these three functions. They are and you do not say sin, you do not say cos or cos, you do not say tan. Okay? Yeah, please do not say sin. I think this would be one fastest way to drive me nuts. Okay, I think this is the minimal respect to these notations. Now, I hope everyone can remember these ratios very well. Now, I want to make sure that that you acknowledge that all these, they are ratio of sides. They're ratios. Okay, and that's what sine, cosine, tangent are for. They tell you what kind of sides are in proportion. Okay, and later on in this course, your ability to identify them is going to be crucial. And I also think that most of you learn these ratios by using SOHCAHTOA, right? Anyone still having trouble to remember these proportions? Anybody? Now, in case you need some secondary help, I can tell you my method of learning all these ratios. Now, I learned these back in my hometown, Hong Kong, because I only came here for high school for 2 years and then continued in college. So when I learned this, it was early. And my teacher taught us a song to remember these ratios. It's a very short song. And it's one of those annoying songs that you will hear once or twice and then it will stick in your head forever. So, so the way he presented this song is like, it's like one of those songs people sing in the mountains. You just yell those a few notes. It's O-A, O-A, H-H. And I was like, what? And he said, O-A, O-A, H-H. And then he wrote on the board, O-A, O-A, H-H. So if you write it this way, opposite over hypotenuse, sine, adjacent over hypotenuse, cosine, opposite over adjacent, tangent. O-A, O-A, H-H. I was like, Okay, sure. And it stuck in my head forever. So I guess it worked. So in case you need it, there's a good alternative right here. All right. So now later on in this course, we will also focus on something called the unit circle. You know what's a unit circle? Was it? A unit, yeah. So when we say unit circle, it's like a 1 unit all around, basically. One, two, three. 1, 2, 3, 4. All right. So now on your notes. Now there's a little empty space on the right hand side. I would like you to go ahead and draw a little circle. And on top of this circle, I want you to draw a pair of axes. Okay. Now, the reason why we call it a unit circle is because it is 1 unit for the radius. The radius is equal to 1. And that's why we call it a unit circle. And if you have a unit circle, there are things that could become a lot easier. So what this the little paragraph saying is this. If we have a little point and we call it P, and let's call this point P with a coordinate of x comma y. So we can actually draw a triangle to connect the origin with this point. And not only we create a triangle, we create a right triangle. What's the hypotenuse? What's the length of the hypotenuse? 1. Okay. And now how should we label our, say, adjacent side right here? Now, this x value, it's called x, right? So that means this length shall be called x, right? So from here to here, it's called x. So the length is also x. And for the height, the opposite side of the triangle, well, that's y. So the height or the opposite side, the length of the opposite side would be known as y. And the angle right here, touching the x-axis at the origin, and we call it theta. Okay, I'll let you label these first. So now, if we have this triangle, then we can start contemplating something. For example, we will say, what is cosine theta in this case for this little triangle right there? How should we express cosine theta? When we think about cosine theta, it's what side over what side? Adjacent over hypotenuse. So we say it is equal to x over 1. So essentially, x is equal to cosine theta. So we say, for the unit circle, the x coordinate is defined to be cosine theta. Now, make sure you can also put this over here. These values for unit circle only. Okay, if it's not unit circle, then we have to do something about it. It's only like this because the radius or the hypotenuse, it's 1, so that's why we can have this nice expression. And sine theta, it's going to be opposite over hypotenuse, so y over 1. So that means y value is simply sine theta. So that means the y coordinate can also be expressed as sine theta. Okay. Now, these values will turn out to be huge in the next couple of weeks and even next couple of months. We are going to do quite a lot of things with these guys. So it's a good idea to understand the basic concept of unit circle. And why do we call the x value as cosine theta? Why do we call the y value as sine theta? And this is why on your paper, it said, well, x has to be between 1 and -1, and y has to be between 1 and -1. So therefore, we'll say the cosine theta would also be in between 1 and -1, and sine theta has to be in between 1 and -1. Okay, I think it's printed on your paper already. But now I have a curious question though. And I have a curious question. I want you to write down this question. My question is this. Now, in general, okay, for any triangle, for any triangles, can sine theta or cosine theta be greater than 1? All right. All right, now ask your neighbor. Okay, I give you a minute to think about this. Can sine theta or cosine theta be greater than 1? Okay, see if you can come up with a good logical conclusion. Okay, ask around. What do you think? Yes or no? Okay, yes or no? Yes or no? So I can give you a hint. I can give you a triangle as a hint. So see if you can make use of triangle and think about if sine theta or cosine theta be greater than 1. Can sine theta or cosine theta be greater than 1? Any guess? Why not? Okay, so the answer is resounding no, because for sine and cosine theta, the denominators are both hypotenuse, right? In a right triangle, hypotenuse is the longest side. So so the hypotenuse is the longest side. So that's why if you ever find out something that sine theta or cosine theta it's bigger than 1, you need to be like, wait a second, something is wrong. That's not possible. Okay, so the hypotenuse is it's the longest side, so therefore you can't really have a value bigger than 1. Now, if you have a unit circle, the radius is not 1, so what do? So we say sine theta is equal to y over r meaning the radius, and so y is equal to r sine theta, and cosine theta it's equal to x over r, so x is equal to r cosine theta. Okay, so again, these things they would be huge in the I believe in the second semester. All right, any questions so far about unit circle? Good. All right, now terminal side of an angle. Okay, so so what we're doing here, it's we're trying to plot the point. So we say 3, 4. So 3, 4 right here, and then we just make a line right here, and then we will say let's go ahead and create a little triangle from here. Create a right triangle here, and we call this angle theta. So we can label the length of these sides 3, 4, and then we would like to obtain the cosine theta and sine theta of the triangle. Okay, so what's the hypotenuse? 5. So if you take the SAT, you should know that this is a 3, 4, 5 triangle. Anyone taking the SAT this Saturday? Okay. All right. So cosine theta, it's going to be, in this case, it's 3 over 5, adjacent over hypotenuse. Sine theta, it's going to be 4 over 5, because it is opposite over hypotenuse. Okay. So if you are given the length of some sides using Pythagorean theorem, you can always find out the missing sides. So for part B and part C, they give you points. So you can go ahead and plot the points, and then do the same thing, obtain the missing side. I think it's the hypotenuse that's missing, and then you will get the ratio. Okay, so I'll give you 2 minutes to work on these part B and part C. I would say when I was doing this kind of exercises the first time doing these trig function stuff, it took me a while to get used to labeling the length of the sides based on the xy values. Like I know how to plot the points, but okay, so this will be the theta. And this is -2, this is 5. So we can say that's the length right here, it's 5. Now, over here for the horizontal side right here, just like physics, direction matters. So instead of saying just 2, we'll call this -2, okay? Direction matters. So what's the hypotenuse? What is the hypotenuse? Okay. So the hypotenuse is going to be square root of 29. So therefore, for cosine theta, it's equal to -2 over root 29. And for sine theta, it's going to be 5 over root 29. Okay. However, because the square root is in the denominator, remember what you need to do if the square root is in the denominator? You need to rationalize it. Okay, we do not allow the denominator to have a square root. So so you just do a square root of 29 over square root of 29. So that's the denominator becomes just a 29. Okay, so the denominator would no longer have a square root. Okay. You all still remember the special right triangle? Yeah, the 30, 60, 90, and then 45, 45, 90. If you are taking the SAT, you have to know the special right triangle. Even though it's printed, it's given to you, but you still have to know them. All right, for this one, this is square root of 5. This is -2. So so the point it's going to be right here. Okay, so that's the theta. Okay, so the length right here it's -2. This right here it's root 5. And what is the radius? What did you get for the radius? Oh, for the hypotenuse. 3. 3. Because root 5 square is 5. And -2 square is 4. So 5 plus 4 is 9. Square root of 9 is 3. So for cosine theta, that's equal to root 5 over 3. And for sine theta, it is -2 over 3. Okay. So now, before we turn to the next page, I just want to make one more. I want to reinforce this point that whenever you do a trig function of an angle, you obtain a ratio. You obtain a ratio. Okay. Now, over here on the next page. So now, what the question, we are like doing the reverse. We are like, hey guys, the angle is in quadrant 4. Cosine theta is 2/5. Could you please find out the sine theta? So when they tell you cosine theta is 2/5, what does the 2/5 mean? Adjacent over hypotenuse. So when we say, oh yeah, adjacent over hypotenuse is in quadrant 4, so 2/5. That's basically what it means. So now, how would you find out the y coordinate of this point? Because this point is currently 2 comma, but we need the y value. How do you find out the missing y value? Well, it's a right triangle. You've got 2 sides already. What can you do? Pythagorean theorem. So if you use the Pythagorean theorem, what would you get for the length? You'll be square root of 21. Square root of 21. 5 square minus 2 square. 25 minus 4. 21. Square root that. But if you just write square root of 21, you'll be wrong. Because it is negative square root of 21. It's in the bottom half of the y-axis, so it should be negative 21. Negative root 21, sorry. Okay, so when you do your sine theta, it's equal to negative square root of 21 over 5. Okay. So do you think you can do part B? Okay. Try part B yourself. So this angle is in quadrant 2. So you go ahead and draw a little triangle in quadrant 2. And they tell you that sine theta it's 5/13. So please find cosine theta. Please find cosine theta. So 5/13 means the ratio of opposite over hypotenuse is 13. So I'm going to draw like 5/13. So this is a little 5 right here. What will be the length of the adjacent side? It will be 12 and it will be negative 12. So so therefore your cosine theta it's going to be negative 12/13. Now, so what you can see here is that you have these positive and negative. And I think we ought to ask a question. And the question is there like a particular way to tell these plus and minuses for these trig functions? And the answer is, of course, yes, there's a way to tell. So on the in the empty space on to the right, I would like you to draw something like this. And please go ahead and you can label 0, pi/2, pi, 3 pi/2. Now, so and of course at the end it'll be 2 pi at the end. I know that you are probably more comfortable with degrees, but I'm just gonna get you more comfortable with radians by seeing more radians. Pi over 2 meaning 90 degrees, 180. This is 270, and this is 360. Okay. Now we have if you ask any calculus student or pre-cal student, they would know how to draw this. This is A, S, T, C, A, S, T, C. Now these letters stand for all, sine, tangent, and cosine. Meaning that if the angle falls into these particular quadrants, then these functions would be positive. Okay, so like for quadrant 1, all trig functions are positive. Why? Why? For both x and the y value, they are both positive. So it doesn't matter whether you have adjacent side or opposite side, you're going to get a positive value. And by the way, hypotenuse is always positive because after you square the adjacent side and opposite side, it ends up positive. But for quadrant 2, why it's only sine function being positive? Well, positive y value, but the x value is negative. So anything that deals with cosine or adjacent side, that's going to be a negative value. And that's why for the question we just did, in quadrant 2, the cosine is negative, okay, for that particular reason. And then for quadrant 3, only tangent is positive because both x and the y are negative. Both x and the y, both adjacent side and the opposite side would be negative. So tangent would be perfectly negative. And for quadrant 4, well, for quadrant 4, the adjacent side is positive. That's nice. Cosine is positive. But the y value, the opposite side, it's going to be negative. Okay. So if you ever need to see it for yourself, which I would strongly encourage you to do that, you can just go ahead and draw a triangle and say, I don't see it. Why is it only cosine being positive in quadrant 4? You draw a triangle, you can label a little theta, and you say, I can see that's a positive adjacent, negative opposite side. And then when you do the ratio, you'd be like, oh, that's why only cosine is positive and the other ones are negative. Any question? Now, so that's gonna transition into the next part, because for the next part, we need to start looking at these angles and start telling which quadrant it is in. So for example, we have cosine of this angle, 4 pi over 9. What quadrant is it in? 1, 2, 3, or 4? How can you tell? All right, now, there are a couple of ways you can tell. Easiest way, as a practice for tomorrow's quiz, Can you go ahead and convert 4 pi over 9 to degrees? How do you know? So pi over 9, it's 20 degrees because pi is 180 degrees. So pi over 9 is 20 degrees times 4, 80 degrees. So one easy way to ensure yourself that you get the right quadrant is that just go ahead and change it to degrees and interpret it that way. But as I said, I do not want you to rely on degrees too often because we are going to use radians exclusively. So how on earth can we tell? Okay. Now, so what I'm going to teach you is this. It's called comparison. But you want to find some reference value to compare. Okay. Now, for example, pi over 2. Okay. So would you agree that for pi over 2, it's the same thing as 2 pi over 4? Would you agree? Are they equal? Or can you see how they're equal? Yes? Can you see how they're equal? Yes? Can you see how they're still equal? Still 1/2 over 1/2 pi? Okay. Now, of course, I know that usually we don't use decimals in a fraction, but this is just for comparison. Can you see this is still pi over 2? Can you see this is still pi over 2? 4.5 pi over 9. This is still pi over 2. So if you want to know what quadrant this little angle falls into, so what you can do is that, 4 pi over 9. Let me think about this. Let me compare this with 4.5 pi over 9, which is pi over 2. Is it pi over 2 yet? And we say, no, not yet. Then we know it's in quadrant 1. Okay, that's how we can tell easily that it is in quadrant 1. Now let's do a few more practice. 5 pi over 4. Which quadrant would it be in? Okay, so in this case, we can compare this with little pi, because pi could be expressed as 4 pi over 4, right? So 5 pi over 4 comparing with 4 pi over 4. So 5 pi over 4 must be in quadrant. It must be in quadrant 3. Okay, because it exceeds 4 pi over 4. Okay, so it's a little comparison that you can do to make your decision even faster. So this is quadrant 3. Okay, so now, so what do we do here? After we know the quadrants, we can tell whether it's positive, negative, or 0. So for example, cosine of an angle that is in quadrant 1, we'll say it is positive, because all angles in the first quadrant, all trig functions in the first quadrant, it's positive. Sine of an angle that's in quadrant 3, that would be negative. Okay, so you just keep referring to A, S, T, C. Okay. And you look at tangent of 2 pi over 3. Where is 2 pi over 3? It's in quadrant 2 because it's not yet a full pi yet. Okay, you can compare this angle with 3 pi over 3. So it's not there yet. So tangent of an angle that's in quadrant 2, it must be negative. And for part D, I think it was changed to cosine of 2 pi over 3. So a cosine of 2 pi over 3, cosine of an angle that's in quadrant 2, so it must be negative. Okay, it must be negative. Yes, no. Where would it be 0? If it somehow hits the one of the axes. Yeah, then it could be 0. Think this one, it's all right. Now I'll let you think about the last question. When will the cosine being positive, but the sine will be negative? Which quadrant would satisfy this? Cosine being positive and yet sine being negative. Would it be quadrant 1? Why not? Yeah, quadrant 1, everything would be positive, right? So so that would be that means we have only one option left to have cosine theta being greater than 0. That must be in quadrant 4. Now, when you write down quadrants, make sure you use Roman numerals. Do not use a regular number. Use Roman numerals to indicate quadrants. So when you go home, all right. So a couple of things you need to know for today. That is, quadrant matters. You need to know how to tell these angles, which quadrant it falls into. The faster you can tell which quadrants they are in, then the easier you can tell whether it's positive or negative. ASTC. Oh, by the way, there's a mnemonic device that some math teachers they came up with to help you understand this or memorize this better. All students take calculus, which I strongly recommend all students to take calculus. I think calculus should be a required course for every single human being on earth. Yes.